Assalamualaikum. We are from class CDCS 2493A. We'll be presenting our group project for linear algebra 2, which is the relationship between study duration and examination score among students. So this is our team members for this group project.
The first one is the introduction. Student life is one of the most important moments. The challenges and the flaws that the students need to face in their student life can help them to be prepared for their future, which is more challenging than it is now. Therefore, examinations can measure the student progress in learning. So for our group project, we choose to find the relationship between the amount of time that students studied per week and the examination score that they will receive. From the data that we take from Kaggle.com, we can do a prediction about the relationship between the study duration and exam score by using the least square solution of quadratic model. There are many other factors that can lead to achieve a high scores in examination, but we choose study duration because it plays a significant role. A well-balanced combination of good time management and a healthy way of study might help the students in unleashing their best performance while they are taking the examination, but they can still maintain their physical and mental health. Next, the objective. Number 1 is to find the relationship between study duration and the exam score received by the students.
Number 2, to calculate the error in the least square solution to evaluate how well the model fits the data.
And number 3 is to evaluate the data by using quadratic model. The data here is from 25 students that contains the amount of time that the students studied per week and the examination score that they received. So the data is from the website Kaggle.com, which is about student performance factors.
From the data, we can construct a least square solution for a quadratic model. As we know, the general form of a quadratic equation is a plus bx plus cx squared. From the data as well, we can make a system of equations. To make it easier, we can also write them in matrix form. For matrix A, the first column must be all ones, second column is x, and the third column will be x squared. Since this is a least square solution, the system is inconsistent. Therefore, we have to do normal system, which is A transpose EX equal to A transpose B. Then, we will get this new matrix form. Next, to solve for coefficients A, B, and C, we can use Gauss-Jordan elimination method. First, multiply the first row with 1 over 25 so that the leading coefficient is 1. Second, we subtract row 1 times 477 from row 2 and subtract row 1 times 9863 from row 3 to make all the entries below 1 0. Next, we multiply the second row with 25 over 19,046 to get leading 1. After that, to make all the entries below 1 become 0, subtract row 2 times 477 over 25 from row 1 and subtract row 2 times 739,524 over 25 from row 3. Next, we have to multiply the third row with 9,523 over 312 million and 369,094 to get leading 1. Lastly, add row 3 times 3,298,045 over 9,523 into row 1 and subtract row 3 times 369,762 over 9,523 from row 2.
By using Gauss-Jordan elimination, we got the value of A, B, and C. Since the best fit quadratic curve is y equal to a plus bx plus cx squared, we can conclude that the best fit quadratic curve is y equal to 60.411 plus 0.5112x minus 0.0069 x squared. Next, we will find the error vector using the formula of E equal to B minus AX as shown. Lastly, we use the value of the error vector to find the magnitude of the error vector, which is equal to 15.672.
Next, move on to residual versus X graph. The scatter plot shows randomly distributed points with no obvious pattern, suggesting that the quadratic model effectively captures the relationship between hours studied and exam score. The cases are scattered above the zero line and the residuals are evenly distributed, indicating a good fit between the model's predictions and the actual data. Lastly, result and discussion. This is the graph of least square quadratic model. This graph illustrates a least square quadratic models analyzing the relationship between hours studied and exam score. The plotted points suggest a non-linear trend where exam score initially increase with study time but may decline after a certain point, as indicated by the quadratic curve shape. The quadratic fit minimizes the sum of quadratic residuals, providing the best approximation for the data curve. The y-axis range from 60 to 64, while the x-axis spans from 0 to 40 hours, implying that the dataset captures moderate study durations and their impact on performance. The graph also highlighted how the quadratic model can reveal more complex patterns than a linear model, as diminishing return from excessive studying.
This study analyzed the relationship between study duration and examination score among students using quadratic model to determine the best fit curve. The quadratic model showed that the error magnitude, which is 15.672, suggesting that it offers the most accurate approximation for the data. Additionally, graphical analysis verified that the quadratic curve best fit data points. This finding highlights how well the quadratic model captures the connection between the number of hours studied and the exam performance in the dataset. This study has successfully identified trends and patterns in student academic behavior by using mathematical modeling tools, providing valuable insight for improving study strategies and future educational planning.